In the first step of cement production, raw limestone is harvested from the earth.
Once harvested, the material is transported to the processing facility, where it will undergo initial crushing and sorting.
Limestone is dropped into the crusher, where it is broken down into smaller, manageable sizes.
Workers carefully monitor the process to ensure the limestone is crushed to the correct size for further processing.
Quality checks ensure the limestone meets specifications before it is sent for further processing.
Once checked, the material is transferred into the facility for the core processing stage.
Skilled workers adjust machinery settings to ensure the proper flow of material into the next stage of production.
The limestone enters a rotating drum, where it is further refined and prepared for the next phase. The grinding process ensures the limestone reaches the correct particle size for cement production.
The processed limestone is temporarily stored until it's ready for blending with other materials.
The material is then transferred to secondary storage before blending.
With the material prepared, we move to the next phase of processing.
The raw materials are transported to the factory, where they will undergo more specialized processing.
Upon arrival, each truck is weighed to ensure the correct amount of materials has been delivered.
Accurate record keeping ensures the integrity of the delivery and its proper allocation in the facility.
Once weighed, the trucks are directed to the unloading area, where forklifts move the materials into the facility.
The material is lifted and moved to a conveyor belt that carries it deeper into the facility for processing.
The limestone is transferred onto a conveyor that takes it into the next processing stage. Each conveyor is controlled to ensure the right pace for the materials as they enter the next phase of production.
Multiple trucks unload at once, ensuring a steady supply of raw materials to the factory.
Once inside, the material is sorted and moved to the correct location based on its type and size. Processed materials are stored in large silos until ready for further refinement.
Once delivered, the material is moved to storage areas, awaiting further processing and blending.
The material is then moved into a hopper for the next phase in cement production.
Once unloaded, trucks leave the facility, making way for the next delivery. With materials stored, the factory is ready for the next stage in the cement-making process.
The cement factory stands as a testament to modern industrial engineering, with towering silos and extensive processing areas.
Security measures ensure that only authorized vehicles are allowed inside the facility, protecting both workers and equipment. Inside, the trucks pass through massive overhead cranes, which will later assist in material handling and movement.
Control panels at the entrance ensure the smooth operation of the entire facility, monitoring everything from material entry to machinery readiness.
The entryway serves as the gateway to the heart of the factory, where materials will undergo refining and transformation.
Inside the factory, workers are on their way to their stations, where they will monitor and control the processing lines.
Incoming material is carefully monitored and moved into the building, where it will be prepared for further processing.
The factory floor is a vast and organized space where workers and machines operate in harmony to process raw materials.
Workers fine-tune the speed of the conveyors to ensure that materials are processed at the correct rate.
The factory's ventilation system helps control the air quality inside, a crucial component in maintaining optimal working conditions.
Workers move swiftly and carefully across the factory floor, ensuring that all operations run smoothly and safely. Governor for News Express. Monitoring and record-keeping are vital aspects of maintaining production efficiency.
In the entry area, machines are carefully monitored and adjusted to ensure they are operating at peak efficiency.
Raw material enters the cleaning and sorting stage, where large debris is removed, ensuring only the finest material moves forward.
Vibrating screens sort the material by size, separating large impurities from the finer particles.
Workers manually clean the materials, removing dust, dirt, and other contaminants before they continue down the line. High-powered air blowers remove any remaining dust, preparing the material for further processing. A magnetic separator removes any metal contaminants, ensuring the material is pure and ready for processing. At each sorting station, workers ensure that only properly sized material continues through the process. Rotating brushes scrub the material further, ensuring a clean surface before it enters the next stage of processing. The factory's dust extraction system helps maintain air quality by capturing fine particles from the sorting process. A washing station removes any remaining dirt or impurities from the material, ensuring it is ready for further processing. Once cleaned, the material is moved to the drying area, where excess moisture is removed to prepare it for grinding. A rotary dryer uses hot air to remove any excess moisture from the material, ensuring it is in the right condition for processing.
Workers carefully monitor the drying process, ensuring the material reaches the correct moisture content.
The drying process is a crucial part of preparing the material for grinding, ensuring consistency and efficiency.
After drying, the material is carefully inspected to ensure it meets the required consistency before moving to the next stage.
Once cleaned and dried, the material is ready for the grinding process, where it will be reduced to fine particles for cement production.
In the core processing stage, the raw material is ground into a fine powder using a large grinding mill.
Inside the mill, steel balls crush the material, grinding it into a fine powder, ready for the next phase.
Skilled workers monitor and adjust the mill's operation to ensure the material is ground to the correct consistency.
Once ground, the material is moved to a mixer where it will be blended with other ingredients for cement production.
In the mixer, the ground material is thoroughly blended, ensuring a consistent mixture for the next steps. After mixing, samples are taken to the lab for testing, ensuring the mixture meets the required standards.
In the lab, the sample is carefully analyzed to ensure it has the correct composition and particle size.
The factory's mixing operations run continuously, ensuring a steady supply of material for the next stages of production.
Once blended, the material is transferred onto a conveyor belt, moving it to the next stage of processing.
The blended material is now on its way to the kiln, where it will be subjected to high temperatures for further transformation.
The kiln, a massive rotating chamber, is where the material is heated to extreme temperatures to create clinker, a key component of cement.
Operators in the control room monitor and adjust the kiln's temperature to ensure the optimal production of clinker.
As the material reaches the required temperature, it undergoes chemical reactions, forming clinker, the heart of cement.
The clinker exits the kiln, where it is cooled rapidly by high-powered fans before it moves to the next processing stage. The cooled clinker is stored in silos, ready to be mixed with gypsum and other ingredients to produce the final product, cement.
Once in the grinding mill, clinker is ground to a fine powder, transforming it into the basic form of cement.
At the blending station, gypsum is added to the ground clinker, controlling the setting time of the final cement product. Skilled workers ensure that the correct ratio of materials is used, adjusting settings to meet product specifications. The blended material is transferred to a storage silo, where it will be stored until it is ready for packaging. The cement is carefully stored, ensuring that it stays dry and ready for packaging or further distribution. Cement is carefully transferred into bags, ready for packaging and shipment to customers.
Once bagged, the cement is stacked onto pallets, ready for storage and transport to distribution centers. Forklifts transport the pallets of cement to the warehouse, where they are stored until shipment. In the warehouse, pallets of cement are carefully organized, ensuring efficient storage and easy access for dispatch. Trucks arrive at the warehouse for loading, ready to transport cement to its final destination. With the cement loaded and ready, the truck heads toward its destination, completing the journey from factory to customer. The entire cement production process is monitored closely from the control room, ensuring smooth operation and quality control.
Before final sealing, workers inspect each batch to ensure the cement meets the highest quality standards.
And so, from start to finish, the cement production process flows seamlessly, creating a product.
The factory is equipped with high-tech automation systems that monitor and control every stage of production.
Workers use advanced touchscreen interfaces to fine-tune machine settings, ensuring precise control over the production process.
Robotic arms are used to handle materials efficiently, sorting and moving them with precision and speed.
Automated systems with advanced sensors ensure that every bag of cement is thoroughly checked for defects before it moves forward.
Multiple automated quality control stations work in tandem, verifying each bag of cement against stringent standards. Automation is not confined to the production line. Robotic systems are also used in material handling and packaging areas throughout the facility. Vision technology enables automated sorting of materials, ensuring that only those that meet specific standards move forward in the production process.
Automated packing systems handle the final stage of packaging, ensuring cement bags are securely packed and ready for shipment.
The loading process is completely automated, with robots and conveyors managing the movement of pallets into storage.
Automated maintenance systems perform regular diagnostic checks, ensuring all machinery operates smoothly and minimizing downtime.
Each bag of cement is labeled with precision by automated systems, ensuring that every product is properly marked for shipment.
Real-time data is displayed on digital dashboards, allowing operators to monitor and control all automation systems with ease.
Operators adjust the settings of the automated production line, ensuring it's ready for the next batch of cement.
Precision is key in the finishing line, where automated systems handle each bag with care to ensure proper alignment and positioning.
At the finishing line, workers monitor the flow of bags, making adjustments to keep production on track.
High-speed packaging machines efficiently place bags of cement into boxes, speeding up the final stages of production. Once sealed, each box is labeled with product details and batch numbers, ensuring easy identification for shipment. Before proceeding to storage, workers perform final checks to ensure the labels are correctly applied and the boxes are intact.
Robots handle the heavy lifting, efficiently stacking cement boxes onto pallets for easy transport.
Before the cement leaves the factory, each bag undergoes a thorough inspection to ensure it meets quality standards. The bags are placed in storage with precision, ensuring easy access when it's time to load them onto trucks or containers.
In the final stages, workers ensure the cement is organized and ready to be loaded into trucks for transport.
Forklifts are used to move the cement from storage to the loading dock, preparing it for shipment to customers. The final product is loaded onto trucks, ready to be delivered to customers and construction sites. With the cement loaded, the truck is sealed and ready to head out, completing the journey from factory to delivery. And with that, the finished product leaves the factory, heading out to serve its purpose in building and construction.
As the trucks drive out, the factory continues its operations, producing cement for the future.
At the Quality Control Lab, samples of cement undergo rigorous testing to ensure they meet the highest standards of quality and consistency.
Compression tests are conducted to determine the strength of the cement,
ensuring it meets the required load-bearing capacity.
Results are carefully monitored, with detailed notes made to ensure the cement meets specifications for construction use.
Setting time tests are done to measure how quickly the cement begins to set, ensuring it has the proper workability for construction.
Fineness tests determine the particle size of the cement, which influences the strength and curing time.
Moisture content is closely monitored, as it affects the cement's stability and its ability to bond effectively.
Chemical analysis is conducted to ensure that the cement contains the correct proportions of elements, such as calcium and silica.
Microscopic analysis allows technicians to examine the cement's chemical structure and ensure it meets quality standards. Chemical reactions are monitored to check for impurities that could compromise the cement's performance.
Test results are documented carefully, with any discrepancies addressed immediately to maintain consistent quality.
The VICAT apparatus is used to test the setting time of cement, which is essential for understanding its workability in construction.
Particle size distribution is another critical factor in cement quality, affecting both strength and curing time.
Consistency tests, like the flow table method, are used to measure the workability of cement, ensuring it meets the required standards.
Once all tests are complete, results are reviewed to confirm that the cement batch meets the necessary quality standards.
Test results are reviewed by the lab team, and a final report is prepared for the production team to ensure the cement is ready for packaging.
Once the cement passes quality checks, it is packed into bags, sealed, and prepared for the final steps of packaging and dispatch.
Workers efficiently stack the cement bags onto pallets, ensuring they are securely packed for shipment.
Once packed and stacked, the pallets are moved toward the loading dock, ready for shipment.
Final checks are performed to ensure the pallet has the correct labeling and is ready for transport.
When the truck arrives, workers guide it into place, ensuring a smooth and safe loading process.
The cement pallets are carefully loaded onto the truck, with workers ensuring they are securely stacked for transport.
Once the truck is fully loaded, the doors are sealed and the cement is ready for its journey. With the cement securely loaded, the truck leaves the factory, ready to deliver the product to its destination.
From above, the full scale of the factory's operations is visible, with trucks coming and going as cement is delivered across the region.
Each shipment is logged for tracking purposes, ensuring all deliveries are documented accurately.
On its way to its destination, the cement will be used in construction projects, from roads to buildings, contributing to infrastructure worldwide.
Meanwhile, inside the factory, the process continues as new materials are prepared and new batches of cement are produced.
To ensure the cement reaches its destination in perfect condition, the final pallets are securely wrapped for protection during transport.
And so, the cycle continues, producing, packaging, and dispatching cement to meet the needs of the world.
And this is how modern factories produce cement from start to finish.